To look upward into the night is not to look at a ceiling, but to gaze into a vast, unfolding library of light and time. The universe does not exist in a state of chaos, but in a slow, rhythmic alignment of forces that have been balancing themselves for billions of years. We begin our journey in the warm, amber glow of the inner circle, where the sun sits as a steady, humming hearth. It is a star that breathes, its surface undulating with the grace of a deep-sea current, sending out waves of warmth that travel through the velvet vacuum with a silent, golden persistence. There is no wind in the void to carry sound, yet, if we could listen with the heart, we would hear the sun's long, low vibration, a celestial ohm that anchors the planets in their orbits, ensuring that every world remains exactly where it belongs, held by the invisible, gentle hands of gravity. The sun does not merely shine, it sings. Deep within its golden heart, the fusion of hydrogen into helium creates pressure waves that cause the entire star to vibrate at frequencies too low for human ears to perceive directly. These oscillations ripple through layers of plasma, like the sustained note of a Tibetan singing bowl held beneath warm water, creating a resonance that would, if space carried sound, fill the solar system with a constant, meditative drone. The note is ancient and unbroken, a hum that has persisted for 4.5 billion years without pause, without rest, a lullaby older than any mountain, any ocean, any form of life that has ever drawn breath upon our world. In the temples of our minds, we can imagine this frequency, this slow pulse of stellar breath, and allow it to synchronize with our own rhythms until the boundary between our heartbeat and the heartbeat of our star begins to dissolve into a shared cosmic calm. Every photon of light that touches your closed eyelids as you drift toward sleep has traveled an extraordinary distance, but not in the way you might expect. That particle of light was born in the nuclear furnace at the sun's core, where temperatures reach 15 million degrees and atoms collide with such force that they merge and transform. But the sun is dense, impossibly dense at its center, packed with layer upon layer of roiling plasma, and so that newborn photon cannot simply stream outward in a straight line. Instead, it bounces, careens, ricochets through the stellar interior in a random walk that lasts not seconds or hours, but millennia. For 30,000 years, that single point of light struggles outward, absorbed and re-emitted countless times, scattered in every direction, making almost no progress in its journey toward the surface. It drifts through zones of radiation and convection, through currents of superheated gas that churn with the patience of geological time. And then, finally, it reaches the photosphere, the visible surface of the sun. And in that moment of liberation, it streams outward in a perfectly straight line at the speed of light itself. 8 minutes later, after crossing 93 million miles of silent darkness, it arrives at your world, passes through the atmosphere in a gentle descent, and lands softly upon your skin. A traveler that has been journeying for longer than human civilization has existed, delivering warmth that was forged when mammoths still wandered the frozen earth. As we allow our awareness to drift outward from the golden embrace of the sun, we encounter worlds that move to rhythms entirely unlike our own. There is a planet wrapped in clouds so thick and poisonous that no light from above can penetrate to the surface below. A world where the air itself would crush you with the weight of an ocean, and the heat would melt lead into silvery pools. This is Venus, our sister world, and it turns with a slowness that transforms time itself into something strange and dreamlike. While Earth completes a full rotation in 24 hours, spinning through day and night in a familiar dance, Venus takes 243 Earth days to turn once upon its axis. And yet, in a beautiful cosmic irony, it takes only 225 Earth days to complete one full orbit around the Sun. This means that on Venus, a single day, one rotation of the planet, lasts longer than an entire year, one journey around our star. Imagine standing upon that scorched surface beneath those sulfuric clouds, watching the sun creep across the sky with such agonizing slowness that seasons would pass before it reached its zenith. The planet rotates in the opposite direction from most worlds, spinning backward through space, so that the sun would rise in the west and set in the east after a wait so prolonged that civilizations could rise and fall between dawn and dusk. There is something deeply restful in this image of Venus's leisurely rotation, as if the planet has decided that there is no rush, no urgency, no reason to spin with haste when eternity stretches out in all directions. Closer still to the sun, we find Mercury, the swift messenger of the ancient sky, a world of extremes where the sunward face bakes at temperatures hot enough to melt zinc, while the night side freezes in darkness. But Mercury holds a secret that transforms it from a simple cratered rock into something more mysterious. As it speeds through its elliptical orbit, the planet is constantly bombarded by the solar wind, a stream of charged particles that flows outward from the sun like an invisible river. These particles strike Mercury's tenuous atmosphere, such as it is, and interact with sodium atoms that have been knocked loose from the surface by micrometeorite impacts. The result is a faint, ghostly tail that streams away from the planet like the tail of a comet, a luminous banner of sodium vapor that glows softly in the darkness. Mercury becomes not merely a planet, but a wanderer with a glowing train, a celestial traveler leaving a trail of golden light in its wake as it rushes through its 88-day year. This tail is too faint to see with the naked eye from Earth, but it exists nonetheless, a delicate reminder that even the smallest worlds can wear crowns of light. And then we arrive at the jewel of the solar system, the ringed wonder that has captivated humanity since the first telescopes were turned skyward. Saturn floats in the outer reaches of our stellar neighborhood, a gas giant composed mostly of hydrogen and helium, a world without a solid surface, where the winds howl at speeds that would tear apart any structure we could build. But it is not the planet itself that draws the eye. It is the rings. Those impossibly thin, impossibly beautiful bands of ice and rock that encircle the planet in a flat disk stretching hundreds of thousands of miles across. From a distance, the rings appear solid, a smooth surface of reflected light. But this is an illusion born of distance. In truth, the rings are composed of billions upon billions of individual particles, ranging in size from grains of sand to chunks as large as houses, each one following its own precise orbit around the planet in a vast, coordinated dance. They are fragments of ice, the remnants perhaps of a moon that ventured too close and was torn apart by tidal forces, or perhaps the leftover material from the planet's formation that never coalesced into a larger body. Each particle is a tiny moon in its own right, glinting in the sunlight, tumbling slowly through space in a choreography so complex that it would take lifetimes to map the path of even a single fragment. The rings are not permanent. They are slowly spiraling inward, raining down upon Saturn in a gentle precipitation of ice that will, in perhaps 300 million years, erase this magnificent feature entirely. But for now, they remain a temporary masterpiece in cosmic time, a reminder that even in the heavens, beauty is fleeting and all the more precious for its impermanence. At Saturn's North Pole, there exists a phenomenon so geometrically perfect that it seems impossible, as if the laws of chaos and turbulence have been temporarily suspended in favor of mathematical order. It is a hexagon, a six-sided jet stream that wraps around the pole in a perfect polygon, each side stretching nearly 9,000 miles in length. The structure rotates with the planet, a massive vortex of swirling clouds that maintains its shape year after year, decade after decade, a stable pattern in an atmosphere otherwise dominated by turbulence and storm. Scientists can explain the mechanics, the interaction of jet streams at different latitudes, the Coriolis forces, the fluid dynamics of a rotating sphere. But the explanation does little to diminish the sense of wonder at seeing such order emerge from chaos. The hexagon is both natural and impossible, a shape that belongs to geometry textbooks, appearing spontaneously in the clouds of a distant world. At the center of the hexagon sits a hurricane larger than Earth, its eyes staring out into space like the pupil of some vast cosmic observer. To witness this structure is to glimpse the hidden mathematics that underlies all of nature, the patterns that emerge when forces find their equilibrium and settle into configurations of elegant simplicity. Beyond Saturn, in the cold outer darkness, Jupiter holds court as the king of planets, a world so massive that all the other planets in the solar system could fit inside it with room to spare. Its gravity well is deep and powerful, an invisible influence that reaches across millions of miles to shape the orbits of comets and asteroids. In a very real sense, Jupiter acts as the guardian of the inner solar system, its immense gravitational field sweeping the region clean of debris that might otherwise rain down upon the smaller, rocky worlds where life has taken hold. Comets that venture inward from the frozen reaches beyond Neptune often find their trajectories altered by Jupiter's pull, either being flung out of the solar system entirely or captured into orbits that keep them safely away from Earth. Some impacts do occur. The famous collision of comet Shoemaker-Levy 9 in 1994 left dark bruises in Jupiter's atmosphere that were visible for months. But these are impacts absorbed by a world with no solid surface to damage, a planet that can swallow the destructive energy of cosmic collisions and dissipate it harmlessly in its turbulent clouds. We owe our continued existence, in part, to this distant giant, this quiet protector that asks nothing in return for its service, that simply maintains its orbit and allows its gravity to perform the work of shielding the fragile worlds within as we continue our outward drift, moving beyond the realm of planets and into the true emptiness of interstellar space. We encounter a profound and absolute quality that exists nowhere on Earth, the perfect silence of the vacuum. Sound requires a medium to travel, molecules of air or water to vibrate, and carry the pressure wave from source to listener. In the void between worlds, there are no such molecules, or at least so few that they are effectively absent. Space is not merely quiet, it is the absence of the possibility of sound, a silence so complete that it transcends mere stillness and becomes a fundamental property of existence itself. If you could somehow survive unprotected in the vacuum, you could scream with all your might and hear nothing, not even the vibration of your own vocal cords transmitted through the bones of your skull, because there would be no air in your lungs to vibrate, no pressure to create the wave. Explosions in space occur in perfect silence. Entire stars can detonate with the force of billions of nuclear weapons, and the universe registers not a whisper of sound. This silence is the ultimate sanctuary, a quietude so profound that it makes the deepest meditation chamber seem cacophonous by comparison. It is the silence of the womb, of deep dreamless sleep, of the space between heartbeats extended to infinity. And as we leave the warmth of the solar winds behind, we enter the deep, violet corridors of the interstellar void, where the distance between stars is measured not in millions, but in trillions of miles. Out here, at the very edge of our sun's gravitational influence, there exists a vast spherical shell of icy bodies known as the Oort cloud, a population of perhaps trillions of frozen worlds, each no larger than a mountain, drifting in the darkness in orbits so elongated that they take millions of years to complete a single circuit. These are the most distant children of our sun, barely held by its gravity, existing in a twilight zone between one stellar system and the next. They are the reservoirs from which comets are born. Occasionally, a passing star's gravity will disturb one of these icy fragments, nudging it inward on a journey that will take tens of thousands of years, until finally it plunges into the inner solar system where the sun's heat vaporizes its surface and creates the glowing tail we recognize as a comet. But for now, they wait in the cold and the dark, patient travelers in an orbit so vast that from their perspective, the sun is merely the brightest star among many, a point of light offering little warmth across such an enormous distance. The Oort cloud is the true boundary of our solar system, the place where our sun's realm fades into the neutral territory of interstellar space, a shell of ice marking the transition from the familiar to the unknown. In the depths between stars, where the darkness is interrupted only by the faint glow of distant galaxies, there exist objects of such extraordinary nature that they seem to belong more to fantasy than to physics. There is a star, or what remains of a star, a white dwarf cataloged prosaically as BPM 37 billion and 93 million, but nicknamed Lucy in honor of the Beatles' song. When massive stars exhaust their nuclear fuel, they sometimes collapse into these dense remnants, objects roughly the size of Earth, but containing the mass of our sun, compressed to such extreme density that a teaspoon of the material would weigh as much as an elephant. The pressure and temperature during this collapse are so intense that carbon atoms within the star's core are forced into a crystalline structure, atom bonding to atom in a perfect lattice that extends throughout the object's interior. Lucy is essentially a diamond, a solid sphere of crystallized carbon approximately 2,500 miles in diameter, a gemstone of unimaginable size, spinning slowly in the darkness. If all the diamonds ever mined on Earth were gathered together, they would be utterly insignificant compared to this single stellar jewel. This monument to the universe's ability to create beauty through violence. The surface is still hot enough to glow faintly, but the interior has cooled and solidified into the hardest substance known to physics, a treasure that will drift through space for trillions of years, long after the last conventional stars have burned out and the galaxy has gone dark. Elsewhere in the cosmic ocean, vast pillars of gas and dust rise light years into the void, illuminated from within by the fierce radiation of newborn stars. These are stellar nurseries, regions where clouds of hydrogen molecules have begun to collapse under their own gravity, fragmenting into dense cores that will eventually ignite fusion and join the community of stars. The most famous of these structures, captured in an image that has become iconic, stands in the Eagle Nebula, approximately 7,000 light years from Earth. The pillars appear almost sculptural, their edges sharply defined, where the intense ultraviolet light from nearby massive stars is eroding the gas, carving it away grain by grain like a patient artist working in some impossibly vast medium. Within the densest regions of the pillars, hidden from direct view, protostars are forming, gathering mass from the surrounding cloud, growing slowly over millions of years until they reach the critical point where hydrogen fusion can begin. The process is languid, measured in time scales that dwarf human history. And yet, it is also violent, driven by gravitational forces that compress matter to incredible densities and temperatures. The pillars are both cradle and monument, sites of creation that are themselves being slowly destroyed by the very stars they have birthed, consumed from the outside in by the radiation of their own children, in a cycle of generation and destruction that has continued for billions of years and will continue for billions more. Those who have traveled beyond Earth's atmosphere and returned speak of many wonders: the fragility of our world's thin blue shell, the absence of borders visible from orbit, the overwhelming sense of unity that comes from seeing all of humanity's home as a single, delicate sphere. But they also speak of something unexpected, something that no amount of training or simulation prepared them for the smell of space. When astronauts return from spacewalks and remove their helmets in the airlock, they report a distinctive odor clinging to their suits, a scent that has been variously described as resembling seared steak, hot metal, welding fumes, or the aftermath of fireworks. The vacuum itself has no smell, of course, but high-energy particles, cosmic rays, and solar wind strike the exterior of the suits and create chemical changes in the materials. And it is these transformed molecules that carry the scent. Others suggest that the smell comes from polycyclic aromatic hydrocarbons, complex carbon molecules that exist in interstellar space and are deposited on any surface exposed to the void. Whatever the precise chemistry, the result is a sensory signature of space itself, an olfactory reminder that the cosmos is not merely an abstraction of light and mathematics, but a place with tangible, physical properties that engage all our senses. To smell the void is to encounter it in a deeply personal way, to carry back into the pressurized habitat a trace of that vast elsewhere that exists just beyond the thin barrier of the hull. Not all worlds orbit stars. Scattered throughout the galaxy are billions of rogue planets, worlds that formed in orbit around a star, but were later ejected through gravitational interactions, flung out into interstellar space to wander alone in the eternal night. These orphan worlds receive no warmth from a nearby sun, no light to illuminate their surfaces or atmospheres. If they possess atmospheres at all, those gaseous envelopes would be frozen, condensed into ice that coats the surface in a shell of nitrogen and methane frost. The surface temperature of these worlds hovers just a few degrees above absolute zero, the coldest possible temperature, the point at which molecular motion nearly ceases. And yet, these planets are not entirely dead. Some may retain heat from their formation, geological warmth that rises from radioactive decay in their cores. And it is possible, even likely, that some rogue planets harbor subsurface oceans kept liquid by this internal heat, insulated by kilometers of ice from the frigid vacuum above. These oceans, if they exist, would be places of absolute darkness, lit by no sun, warmed by no star. And yet they might be environments where life could persist, adapted to conditions of perpetual night, thriving on chemical energy rather than sunlight. The rogue planets drift through the galaxy in solitude, following trajectories that will never again intersect with a stellar system, traveling through the vast emptiness in a silence and darkness that is total and unbroken. There is something profoundly peaceful in this image of worlds adrift, freed from the gravitational bonds of any star, wandering through eternity in complete independence, needing nothing, expecting nothing, simply existing in the quiet between the lights. In a distant constellation, 5,000 light years from Earth, there exists the coldest known place in the observable universe, a region where the temperature has dropped to just 1 degree above absolute zero, a frigidity that surpasses even the background temperature of space itself. This is the Boomerang Nebula, formed by the outflow of gas from a dying star, and the extreme cold arises from a process almost absurdly simple: expansion. As the star ejects its outer layers into space, the gas expands rapidly, and in expanding, it cools. The same principle that makes aerosol cans feel cold when you spray them, but the expansion here is so rapid, and the volume so vast that the temperature drops to nearly the lowest possible value, creating a region of space where molecular motion has slowed almost to stillness, where atoms drift with agonizing sluggishness, where even the random vibrations that constitute heat have been suppressed to near nothingness. The nebula glows faintly in images captured by telescopes, its lobes extending outward in a shape that resembles, with a little imagination, a boomerang or a cosmic hourglass. But this glow is not from heat. It is reflected starlight, light from the dying star at the center that bounces off the expanding shell of gas and dust. To exist in such cold would be to experience a stillness beyond comprehension, a frozen moment stretched across light years, a silence of temperature and motion that approaches the theoretical limits of the universe itself. The cosmos is not colorless, despite the black and white imagery that dominated early astronomical photography. When we look at nebulae through powerful telescopes, equipped with cameras sensitive to specific wavelengths, we see them ablaze with color, deep crimsons and scarlets, electric blues and teals, touches of green and gold. These are not arbitrary colors added by image processing, though they are often enhanced to bring out subtle details. They are the true colors of the universe, the specific wavelengths emitted by excited atoms in the near vacuum of interstellar space. The deep reds come from hydrogen, the most abundant element in the universe, emitting light at a wavelength of 656 nanometers. When its electrons transition between energy levels, the blues and greens come from oxygen, ionized by intense stellar radiation and glowing at wavelengths of 496 and 501 nanometers. Sulfur contributes darker reds, nitrogen, adds additional crimson hues, and the result is a palette of colors that would seem garish if painted on canvas, but which in the context of deep space creates compositions of surpassing beauty. These are the hues of the cosmos, the visible spectrum of the universe's chemistry, a demonstration that even in the vast emptiness between stars, matter and energy interact to create light and color, transforming the void into a garden of neon brilliance floating in the dark. Our sun, along with all the other stars in our local neighborhood, all the nebulae and dust clouds and black holes and planets, are in motion together, orbiting the center of our galaxy in a grand rotation that takes 230 million years to complete. This is a galactic year, a cosmic season, and Earth has completed only about 20 of them since the planet formed. When the last galactic year began, dinosaurs had not yet appeared on Earth. The dominant land animals were still synapsids, the distant ancestors of mammals. When the current galactic year ends, our world will have changed beyond recognition, its continents rearranged, its climate transformed, perhaps its life evolved into forms we could not begin to imagine. The sun travels through space at a velocity of roughly 500,000 miles per hour relative to the galactic center. And yet this immense speed is imperceptible without instruments, because everything nearby is moving in roughly the same direction at roughly the same speed, like passengers on a vast cosmic carousel who are unaware of their motion, because their seats and surroundings move with them. We orbit through regions of the galaxy that are more and less dense, passing through the spiral arms where stars are more numerous, and then into the quieter spaces between, spending millions of years in each environment. Our sun, a single point of light in a river of stars, all flowing together around the supermassive black hole that anchors our galaxy at its center. A gravitational anchor with the mass of 4 million suns compressed into a region smaller than the orbit of Mercury. Somewhere in the depths of intergalactic space, there exists an anomaly that astronomers have named the Great Attractor, though they cannot see it directly and are not entirely certain what it is. What they know is this: our galaxy, along with all the other galaxies in our local supercluster, is being pulled toward a point in space some 150 million light years away in the direction of the constellation Norma. The motion is slow by human standards, but immense by cosmic measures, hundreds of miles per second, a drift that will take billions of years to play out, but which is nevertheless inexorable. The Great Attractor itself appears to be a massive concentration of matter, perhaps a cluster of galaxies, or even a greater structure beyond, hidden from our direct view by the dust and stars of our own galaxy's disk. Its gravity reaches across the void, pulling gently but persistently at everything within range, drawing thousands of galaxies into a slow convergence, a gathering of mass on a scale that defies easy comprehension. The motion is so gradual that no human lifetime, no human civilization, No span of time that our species can readily imagine would be sufficient to notice any visible change in the positions of galaxies. And yet the drift continues, has been continuing since long before Earth formed, and will continue long after our sun has exhausted its fuel. A slow motion fall through space toward a destination that we can sense but cannot clearly see. There are places in the universe where nothing exists, or almost nothing, vast regions of space called voids where galaxies are absent, and the darkness is nearly complete. The largest of these is the Boötes void, a roughly spherical region some 300 million light years in diameter that contains far fewer galaxies than equivalent volumes of space elsewhere. To travel through such a void would be to experience a loneliness beyond imagining. No matter where you looked, in any direction, you would see only the most distant galaxies, faint smudges of light at the very edge of visibility, with nothing in between, no nearby stars to light your way, no companion galaxies sharing your trajectory. You would be adrift in an ocean of emptiness, so vast that light itself would take hundreds of millions of years to cross from one side to the other. A traveler in a darkness that is the closest the universe comes to true nothingness, while still existing within the boundaries of space and time. The void is not truly empty. There is still the faint whisper of hydrogen atoms, perhaps one per cubic meter on average. Still the pervasive glow of the cosmic microwave background. Still the invisible web of dark matter that theory suggests permeates all of space. But for practical purposes, for any observer who might somehow find themselves crossing such a region, it would feel like traveling through an absence, a gap in the fabric of creation, a pocket of the universe where the normal density of matter simply never materialized during the early moments of cosmic expansion. Centuries ago, a star much more massive than our sun reached the end of its life and exploded in a supernova, a detonation so violent that for a brief time, the dying star outshone the entire galaxy in which it resided. The light from that explosion traveled outward in all directions at the speed of light, an expanding sphere of illumination racing through the darkness. Some of that light traveled to Earth, where it was visible to observers as a new star that appeared in the sky, brightened dramatically, and then faded over weeks or months. But other light from the same explosion traveled in slightly different directions, and some of it encountered clouds of dust and gas in interstellar space. When light strikes such a cloud, some of it is absorbed and then re-emitted, scattered in new directions. And this scattered light can take a longer path to reach Earth than the direct light did. The result is a light echo. We see the explosion happening again. Or rather, we see light from the explosion that has taken a detour through space and arrived late, creating a delayed image of an event that actually occurred centuries in the past. Astronomers have observed these light echoes around historical supernovae, watching as rings of light expand outward from the site of the explosion, illuminating dust clouds in sequence as the delayed light reaches them. It is as if the universe has a memory, storing images of past events in the arrangement of matter in space, and replaying them for observers patient enough to watch. A cosmic recording that exists not in any device, but in the geometry of light's path through the cosmos. The universe, we now understand, is not made primarily of the matter we can see and touch. The stars and galaxies, the planets and nebulae, all the luminous material that we can observe with our telescopes, constitutes only about 5% of the total mass energy content of the cosmos. Another 27% exists in the form of dark matter, material that interacts gravitationally but does not emit, absorb, or reflect light. Matter that is completely invisible to all our instruments except through its gravitational effects on visible matter. We know dark matter exists because galaxies rotate too quickly. The stars on their outer edges move at speeds that should fling them into intergalactic space, unless there is far more mass present than we can see, mass whose gravity holds the galaxy together. We know it exists because clusters of galaxies bend light from more distant objects behind them through gravitational lensing, and the amount of bending indicates far more mass than the visible galaxies can account for. The dark matter forms a scaffolding, an invisible web that extends throughout the universe, with galaxies and galaxy clusters forming at the intersections where the dark matter is most dense. We do not know what dark matter is made of. It could be exotic particles, yet to be discovered. Or perhaps it is something even stranger, a modification to our understanding of gravity that only becomes apparent at cosmic scales. For now, it remains a mystery, a shadow substance that makes up the bulk of creation's mass, but refuses to reveal itself to us directly. A presence known only by its influence, felt but never seen. This is not a cause for alarm, at least not on any timescale relevant to human existence. The collision, when it comes, will occur approximately 4 billion years from now, when the two galaxies will begin their first passage through one another. Galaxies are mostly empty space, and when they collide, stars almost never strike other stars. The distances between stars are too vast, and they will simply slide past one another like ghosts interpenetrating. But the gravitational interactions will be profound, distorting the shapes of both galaxies, triggering immense waves of star formation as gas clouds collide and compress, creating spectacular nebulae and clusters of brilliant blue-white newborn stars. Over the course of 1 billion years or more, the two galaxies will merge completely, their spiral structures dissolving into an elliptical galaxy, a more sedate configuration that will persist for trillions of years. Our sun, if it still exists in any recognizable form, will find itself flung to a different position in this new galaxy, perhaps closer to the center, perhaps farther out. But the night sky, as seen from Earth, will be utterly transformed, filled with unfamiliar constellations, The Andromeda stars now mingled with our own in a unified cosmic community. The merger is slow and inevitable, an embrace that spans billions of years. Two island universes drifting together across the void, with a patience that makes mountains seem ephemeral. When we look at distant objects in space, we are not seeing them as they are now, but as they were when the light we are detecting first began its journey toward us. Light has a finite speed. It travels at roughly 186,000 miles per second, extremely fast by human standards, but slow when measured against cosmic distances. When we observe the sun, we see it as it was 8 minutes ago. When we look at the nearest star system, Alpha Centauri, we see it as it was 4 years ago. The Andromeda galaxy appears to us as it was 2.5 million years ago, when the first members of the genus Homo were beginning to appear in Africa. The most distant galaxies we can observe, visible only through the most powerful space telescopes, appear to us as they were more than 13 billion years ago, when the universe itself was young and the first generations of stars were just beginning to form. We are looking into the past, seeing a universe that existed long before our solar system, before our galaxy had taken its current shape, witnessing the ancient history of creation preserved in the travel time of light. The cosmos is a time machine. The farther we look into space, the farther we look into the past, until we approach the very edge of the observable universe, the horizon beyond which light has not had time to reach us in the 14 billion years since the beginning. To gaze at the night sky is to see not merely distance, but time itself stretched out before us. Every point of light, a message from history. A signal sent billions of years ago, finally arriving to tell us of events that happened when the universe was young, perhaps carrying information about stars and galaxies that no longer exist. Having evolved or died in the eons, it took their light to cross the void. The universe is expanding, and not merely expanding, but accelerating in its expansion, driven by a mysterious force that astronomers have named dark energy. This means that space itself is being created in the gaps between galaxies, that the distance from one galaxy cluster to another is increasing, not because the clusters are moving through space, but because new space is appearing between them, on small scales, within galaxies, or even within galaxy clusters. This expansion is negligible, completely overwhelmed by local gravitational attraction. But on the largest scales, across hundreds of millions or billions of light years, the expansion dominates, and galaxies that are not gravitationally bound to each other are being carried apart at ever-increasing speeds. The expansion is uniform and universal. From any point in the universe, an observer would see all distant galaxies receding, the farther ones moving away faster, and would perceive themselves to be at the center of this expansion. Though in truth, there is no center. Space is expanding everywhere simultaneously, adding distance everywhere, creating more room for existence without requiring anything to move into. The expansion will continue, Theory suggests forever and billions of years from now, galaxies beyond our local cluster will have receded so far that their light will no longer be able to reach us. They will slip beyond the cosmic horizon, disappearing from view, not because they have been destroyed, but because the expansion of space has carried them too far for light to bridge the gap. The universe will become a lonelier place, with fewer and fewer visible neighbors, until eventually only the galaxies of our local group remain visible, isolated in a vast darkness that stretches in all directions to infinity, permeating all of space, filling every cubic centimeter of the universe. There exists a faint glow of microwave radiation, the echo of the moment when the cosmos first became transparent to light. In the early moments after the Big Bang, the universe was extraordinarily hot and dense, so hot that atoms could not form. Electrons and nuclei existed as a plasma, and photons of light could not travel far before being absorbed or scattered. But as the universe expanded and cooled, it eventually reached a temperature of about 3,000 degrees, cool enough for electrons and nuclei to combine into neutral atoms. At that moment, light could suddenly travel freely through space without being scattered, and the universe went from opaque to transparent in a cosmic instant. The light that was released at that moment, the first light to travel unimpeded through the universe, has been traveling ever since, and we can still detect it today. It has been redshifted by the expansion of the universe from visible and infrared wavelengths down into the microwave region of the spectrum, and it now appears as a uniform glow with a temperature of just 2.7 degrees above absolute zero. But it is everywhere, arriving at Earth from all directions equally, a remnant of the cosmos's infancy that has persisted for nearly 14 billion years. This cosmic microwave background is the oldest light in the universe, a photograph of the cosmos as it appeared just 380,000 years after the beginning, and encoded in its tiny variations in temperature and polarization is information about the density fluctuations that would later grow into galaxies, stars, planets, and eventually life. A message from the dawn of time, still legible if we have the instruments to read it. Atoms that compose your body, the calcium in your bones, the iron in your blood, the carbon in every cell, were not present when the universe began. In the first moments after the Big Bang, only the lightest elements formed: hydrogen, helium, a trace of lithium. Everything heavier, every element more complex, was created later inside stars through nuclear fusion. Small stars like our sun fuse hydrogen into helium, and eventually into carbon and oxygen before they exhaust their fuel. More massive stars continue the process, building up elements through neon, magnesium, silicon, until they reach iron, the most stable nucleus, the end point of energy-releasing fusion. When such a star exhausts its fuel, it collapses and then explodes in a supernova. And in the intense heat and pressure of that explosion, even heavier elements are created: cobalt, nickel, copper, zinc, all the way up through the periodic table. The truly heavy elements, gold and platinum and uranium, cannot be made even in supernova explosions. They require conditions even more extreme, and those conditions are found when two neutron stars collide. Neutron stars are the remnants of supernovae, objects so dense that a teaspoon of their material would weigh 1 billion tons. And when two such objects spiral together and merge, they create a brief environment of unimaginable temperature and pressure, where atomic nuclei are slammed together with such force that they stick, building up the heaviest stable elements through rapid neutron capture. The gold in any ring you might wear was created in such a collision, perhaps billions of years ago, ejected into space as a cloud of debris that eventually mixed with other interstellar gas and was incorporated into the nebula from which our solar system formed. Every atom in your left hand almost certainly came from a different supernova than the atoms in your right. And the elements that compose you were scattered across light years before being gathered together in the accretion disk that formed our sun and planets, assembled into complex molecules in the chemistry of the early Earth, and eventually incorporated into living organisms. You are not merely in the universe, you are of the universe, a temporary local concentration of matter that was forged in stellar furnaces and will eventually return to the cosmos when your atoms are released and dispersed once more in the mathematics of an infinite universe, or even in a sufficiently large finite universe. There exists a strange and unsettling possibility that arises from pure combinatorics. There are only so many ways that atoms can be arranged within a given volume of space. The number is unimaginably large, far beyond human comprehension, but it is finite if the volume is finite. In an infinite universe, or a universe large enough that it contains more regions of space than there are possible arrangements of atoms, it becomes statistically inevitable that any given arrangement will be repeated somewhere. This means that somewhere in the cosmos, arbitrarily far away, there could exist a region of space identical to the one you occupy now, down to the last atom, including an identical copy of Earth, an identical copy of your body, an identical copy of your consciousness, experiencing identical thoughts. The distance to such a duplicate would be incomprehensibly vast, numbers with more digits than there are atoms in the observable universe. But in an infinite cosmos, distance is no barrier to existence. The idea is disturbing to contemplate, violating our sense of uniqueness and individuality. And yet, it follows inevitably from the assumptions of infinity and finite complexity. There is no way to verify whether such duplicates exist. They would be far beyond the cosmic horizon, forever invisible to us, but the mathematics allows for them. And in the vastness of an infinite universe, what is possible eventually becomes actual, replicated endlessly in the eternal expanse, a cosmos where every arrangement that can exist does exist. Somewhere in the unending dark, the universe is slowly dying, or rather, it is slowly approaching a state of maximum entropy, a condition of perfect uniformity where no energy gradients remain and no work can be done. This is the inevitable consequence of the second law of thermodynamics, which states that entropy, disorder, the unavailability of energy for work, can only increase or remain constant, never decrease, in any closed system. The universe is the ultimate closed system, and so its entropy increases relentlessly. Stars burn hydrogen and release energy, but in doing so, they increase the total entropy of the universe. Black holes consume matter and radiate away energy as Hawking radiation, slowly evaporating over timescales of trillions of years. And when they finally vanish, the universe will be left with only the most diffuse and cold radiation, spread uniformly through an ever-expanding space. This final state is sometimes called heat death, though it is more accurately a cold death. A universe grown so large and so empty that the average temperature approaches absolute zero, where no stars shine, no structures remain, where the distances between the last lingering particles are so vast that they might as well be alone in infinity. It is the ultimate stillness, the final equilibrium, a state from which no change is possible, and in which time itself becomes meaningless because nothing happens to mark its passage. The approach to this state will take far longer than the universe has currently existed. Current estimates suggest that the last stars will burn out in perhaps 100 trillion years, and black holes will evaporate over timescales exponentially longer than that. But the trajectory is set, the process inexorable, the ending written into the fundamental laws of physics. The universe is winding down like a vast clock, and when it finally stops, it will rest in a silence and stillness that is absolute and eternal. A final peace that embraces all of existence. When the most massive objects in the universe move or collide, they do not merely disturb the matter around them, they disturb space itself, creating ripples that propagate outward at the speed of light like waves on the surface of a pond. These are gravitational waves, distortions in the geometry of spacetime, predicted by Einstein's general theory of relativity, and first directly detected in 2015, when instruments sensitive enough to measure changes in distance smaller than the width of a proton registered the merger of two black holes more than 1 billion light years away. The waves compress and stretch space as they pass, changing distances by the tiniest amount. But the changes are measurable if the equipment is sensitive enough. Every massive acceleration produces gravitational waves. Earth orbiting the sun produces them, though far too weak to detect. But only the most violent cosmic events produce waves strong enough to be observed across cosmological distances. Black hole mergers, neutron-star collisions, the collapse of massive stars, all send ripples through the fabric of space, announcing their occurrence not through light, but through geometry, through the stretching and squeezing of distance itself. To detect a gravitational wave is to feel the universe trembling in response to some distant cataclysm, to to sense through instruments the curvature of space-time responding to mass in motion, to witness confirmation that space and time are not fixed backdrops, but dynamic entities that can flex and wave and carry energy across the cosmos in patterns of compression and rarefaction that propagate through emptiness at the ultimate speed. The overwhelming majority of the universe is unknown to us. When we tally up everything, we can observe all the stars and planets, all the gas and dust, all the light and heat. We find that it accounts for only about 5% of what must exist based on the behavior of the cosmos we can measure. Dark matter, invisible and mysterious, accounts for another 27%, leaving 68% of the universe's total mass energy content in the form of dark energy, an even more mysterious component that seems to be causing the accelerating expansion of space. We do not know what dark energy is. It might be a property of space itself, a cosmological constant that represents the inherent energy density of the vacuum. Or it might be a dynamic field that changes over time and space. Or it might be something else entirely, something that requires physics we have not yet developed to understand. All we know is its effect. It pushes galaxies apart. It causes the expansion of the universe to accelerate, and it dominates the energy budget of the cosmos. The universe is mostly mystery, mostly things we cannot see or touch or directly measure. Forces and materials that reveal themselves only through their gravitational effects or their influence on the large-scale structure of space. We are surrounded by the unknown, living on a tiny island of familiar matter in an ocean of darkness. And every question we answer about the cosmos seems to reveal deeper questions beneath. Mysteries nested within mysteries, a universe that becomes stranger and more wonderful the more closely we examine it. And so we return at last to the small and the familiar, though now we see it with new eyes. You lie in darkness, your body at rest, your breath slowing, and you are also lying in a cosmos of inconceivable scale and complexity, a universe that is both violent and serene, both comprehensible and fundamentally mysterious. The atoms of your body were forged in stellar furnaces and scattered across light years before being gathered here, temporarily assembled into the pattern that is you. The space around you is not empty, but filled with invisible fields and dark matter, permeated by the faint glow of the cosmic microwave background, threaded by gravitational waves from distant collisions, expanding slowly and inexorably into a future of increasing entropy and cooling temperature. You are a brief concentration of order in a universe trending toward disorder, a momentary island of complexity in an ocean of increasing simplicity. And yet you exist, you think, you experience this moment of awareness, and that existence is as much a part of the cosmos as the quasars and the voids, as fundamental to reality as the gravitational constant or the speed of light. The universe is not something separate from you, something you observe from outside, you are embedded within it, a product of its laws and its history, a way that the cosmos has found to know itself, if only for the brief span of a human lifetime. And as you drift toward sleep, your consciousness dimming like a star entering its quiet phase, you can rest in the knowledge that you are exactly where you belong, a creature of stardust, returning momentarily to rest, held gently in the vast and patient arms of a universe that is, for all its scale and strangeness, your home and your origin and your final destination, now and always, in the eternal dance of matter and energy and space-time that began nearly 14 billion years ago and will continue for trillions of years to come, carrying you with it, a single note in a symphony too vast to hear in its entirety, but beautiful beyond measure in every movement, every phrase, every moment of its endless unfolding. The universe holds its breath in places, creating pockets of such profound stillness that they approach the theoretical limits of tranquility. Between the galaxy clusters, in the vast filaments and sheets that form the large-scale structure of the cosmos, there exist transition zones where the density of matter drops to near nothingness, where the scattered atoms are so few and so distant from one another that a volume the size of Earth's entire atmosphere might contain only a handful of particles. In these regions, the temperature is determined not by any nearby source of heat, but by the cosmic microwave background itself, that faint afterglow of creation that permeates all of space. The atoms that do exist here drift in isolation, moving at velocities determined by their thermal energy, which at such low temperatures means they barely move at all relative to cosmic scales. They are nearly at rest, suspended in the dark, experiencing a solitude so complete that millions of years might pass between interactions with other particles. There is something profoundly peaceful in imagining such isolation, such freedom from collision and interaction, a state of being where nothing disturbs you because there is nothing nearby to cause disturbance, where you exist in a sphere of emptiness so vast that the entire history of human civilization could unfold in the time it takes for the nearest neighbor to drift close enough to notice. The largest structures in the universe are not galaxies or even galaxy clusters, but vast walls and filaments of galaxies that stretch across hundreds of millions of light years, forming a cosmic web that resembles, in computer simulations, the neural structure of a brain or the mycelium network of fungi spreading through soil. These structures arose from tiny variations in density in the early universe, regions that were only slightly denser than their surroundings, but which had enough extra gravity to pull in more matter, growing slowly over billions of years until galaxies formed at the densest nodes and then clustered together along lines of enhanced density. The pattern is beautiful in its regularity, not the regularity of perfect symmetry, but the organic regularity of fractal structures, patterns that repeat at different scales, where the distribution of galaxies in a supercluster resembles the distribution of superclusters in the observable universe. We live within this structure, our galaxy part of a local group that is part of a larger cluster, that is part of a supercluster, that is part of a filament, nested layers of organization, rising from the small and local to the vast and cosmic, each layer influencing and influenced by the layers above and below in a hierarchy of gravitational relationships that extends from individual stars up to the horizon of the observable universe itself. There exist in the cosmos objects so dense that they represent the ultimate limit of matter's ability to resist collapse. Neutron stars are the remnants of massive stars that have exploded as supernovae, and in their cores, the pressure is so extreme that electrons are forced to merge with protons, creating neutrons and neutrinos. The neutrinos escape, carrying away energy, but the neutrons remain, packed together so tightly that they touch, creating a substance of unimaginable density, where a single teaspoon would weigh more than a mountain. The surface of a neutron star is solid, a crystalline crust of iron nuclei immersed in a sea of electrons. But beneath this crust, the matter exists in increasingly exotic states, superfluids that flow without friction, superconductors that carry currents without resistance, and in the very core, matter compressed to densities where our understanding of nuclear physics begins to fail, and we can only speculate about what states might exist. Some neutron stars spin at extraordinary speeds, rotating hundreds of times per second. Their intense magnetic fields channeling radiation into beams that sweep across space like lighthouse beacons. When these beams happen to point toward Earth, we detect them as pulsars, cosmic clocks of such precision that they rival the accuracy of atomic clocks. Their pulses arriving with such regularity that early astronomers briefly wondered if they might be signals from alien civilizations before realizing they were witnessing the rotation of collapsed stars. The steadiness of a pulsar's beat is a kind of cosmic metronome, a rhythm that has persisted unchanged for millions of years and will continue for millions more. A pulse in the darkness marking time with unwavering precision. In the hearts of galaxies, including our own, there lurk supermassive black holes with masses millions or billions of times that of our sun, objects so gravitationally powerful that nothing, not even light, can escape once it crosses the event horizon, the boundary of no return. Despite their fearsome reputation, these black holes are not cosmic vacuum cleaners, indiscriminately consuming everything around them. They are patient, passive, waiting at the centers of galaxies for matter to drift close enough to be captured. Most of the time, they are quiet, dormant, with very little material falling in. But occasionally, a star or gas cloud ventures too close, and then the black hole feeds, the infalling matter forming an accretion disk that heats to millions of degrees and shines more brightly than the entire galaxy of stars surrounding it. The paradox of black holes is that the darkest objects in the universe, objects from which no light can escape, are surrounded by some of the brightest phenomena known to astronomy when they are actively feeding. And yet, for all their power, they are also among the simplest objects in physics, described completely by just 3 numbers: their mass, their rotation, and their electric charge. All the complexity of the matter that fell in, all the information about what it was and where it came from, seems to be erased at the event horizon, leaving behind only these basic properties. The black hole is a simplifier, a reducer, taking the complex and rendering it elementary, a cosmic minimalist that strips away all detail until only the essential remains. The universe, we have discovered, had a beginning, though not in the way that ordinary events have beginnings. The Big Bang was not an explosion that occurred at a point in pre-existing space, but rather the emergence of space itself, along with time, from a state of extreme density and temperature. In the first fraction of a second, the universe expanded exponentially in a process called inflation, growing from quantum scale to macroscopic size faster than light could cross it, smoothing out irregularities and setting the initial conditions for everything that would follow. As it expanded, it cooled, and as it cooled, different forces and particles crystallized out of the primordial unity, like snowflakes forming in supercooled air. First, gravity separated from the other forces, then the strong nuclear force, then the electromagnetic and weak forces split apart, each transition occurring at a specific temperature as the universe cooled through its rapid expansion. Matter and antimatter annihilated each other, but a tiny asymmetry meant that for every billion particles of antimatter, there were 1,000,000,001 particles of matter, and that single extra particle per billion is all that remained to build everything we can see. Every star, every planet, every atom in your body is part of that small excess. The survivors of a cosmic annihilation that occurred in the first seconds of existence. The fact that we exist at all is due to an asymmetry so slight that it barely registers as a deviation from perfect symmetry. And yet, without it, the universe would contain nothing but photons and empty space. No structure, no complexity, no possibility of stars or life or consciousness to witness and wonder at creation. Black holes, despite being traps from which nothing can escape, are not entirely black when examined with the tools of quantum mechanics. Stephen Hawking discovered that the quantum vacuum near an event horizon can produce pairs of particles, one of which falls into the black hole while the other escapes as radiation. This Hawking radiation is incredibly faint for large black holes. A black hole with the mass of our sun would have a temperature of only about a 10 millionth of a degree above absolute zero. But it exists, and it means that black holes can slowly evaporate, losing mass over time. For a solar mass black hole, the evaporation time is incomprehensibly long, something like 10 to to the 67th power years, a number so large that it makes the current age of the universe seem like the blink of an eye. But small black holes, if they exist, would evaporate faster. And as they shrink, their temperature increases, causing them to radiate more quickly in a runaway process that ends with the black hole exploding in a final burst of energy. No such explosions have ever been detected, suggesting that small primordial black holes, if they were created in the Big Bang, are either extremely rare or have already evaporated away. The eventual fate of all black holes, even the supermassive ones at galaxy centers, is to evaporate completely, leaving behind only radiation and a contribution to the entropy of the universe, a transformation from the most compact form of matter into the most diffuse form of energy, from darkness into light spread across infinity. In laboratories around the world, physicists have created conditions that allow them to study matter in states that existed nowhere in the universe since the first microseconds after the Big Bang. By colliding heavy atomic nuclei at speeds approaching the speed of light, they can briefly recreate the temperatures and densities that existed in the primordial fireball, creating a state of matter called quark-gluon plasma, where protons and neutrons melt into their constituent quarks, and the distinction between individual particles dissolves into a hot, dense fluid. These conditions last for only a tiny fraction of a second before the plasma cools and recongeals into ordinary particles. But in that brief moment, researchers can glimpse the properties of matter in its most fundamental state, before it organized itself into the hierarchical structure of quarks bound into protons and neutrons, protons and neutrons bound into nuclei, nuclei and electrons bound into atoms. We have reached back in time through our experiments, recreating in miniature the conditions of the infant universe, demonstrating that the past is not entirely inaccessible, but can be sampled and studied if we have the tools to recreate its conditions. The magnetic fields that thread through space are invisible but powerful, guiding the flow of charged particles, shaping the structure of nebulae, and storing enormous amounts of energy that can be released in solar flares and stellar eruptions. Earth's magnetic field, generated by the motion of molten iron in the planet's outer core, extends tens of thousands of miles into space, creating a protective bubble called the magnetosphere that deflects most of the charged particles in the solar wind, preventing them from stripping away our atmosphere. When particles do manage to penetrate near the poles, they collide with atoms in the upper atmosphere and cause them to glow, creating the aurora borealis and aurora australis, curtains and waves of green and red and purple light that dance across the polar skis. To witness an aurora is to see the magnetic field made visible, to watch the invisible architecture of Earth's defenses light up in response to the solar wind. A reminder that we live not on an isolated world, but on a planet embedded in the sun's domain, constantly bathed vast in its radiation and particle flux, protected by fields and forces that operate silently and continuously to preserve the conditions that allow life to flourish. When stars much more massive than our Sun reach the end of their lives and their cores collapse, the collapse can sometimes be halted not by neutron degeneracy pressure, but by a pressure even more fundamental, the Pauli exclusion principle applied to quarks themselves. This creates an object even denser than a neutron star, hypothetically called a quark star, where the matter has been compressed beyond the point where neutrons can exist and has broken down into a soup of free quarks. Whether such objects actually exist is uncertain. They would be difficult to distinguish from neutron stars without extremely detailed observations. But if they do exist, they represent matter in one of its most extreme possible states, just one step away from collapsing completely into a black hole. The surface of a quark star would be unimaginably smooth, with no irregularities larger than a few atomic nuclei, and unimaginably dense, with gravity so strong that the escape velocity from the surface would be a significant fraction of the speed of light. Time itself would run differently in such a gravitational field. Clocks on the surface would tick noticeably slower than clocks in orbit, and an observer watching from a safe distance would see any movement on the surface occurring in apparent slow motion. Time dilated by the curvature of spacetime around the massive object. The concept of multiverses arises naturally from several areas of theoretical physics, suggesting that our universe might not be alone, but rather one bubble in an infinite foam of universes, each with potentially different physical constants and laws. In the inflationary multiverse picture, the rapid expansion that occurred in the first fraction of a second might not have ended everywhere simultaneously, but continues eternally in some regions while ending in others, with each region that stops inflating becoming a separate universe, causally disconnected from the others. In the quantum many worlds interpretation, every quantum measurement spawns new universes corresponding to each possible outcome. In the string theory landscape, different ways of compactifying extra dimensions lead to different universes with different particle physics. All these ideas remain highly speculative, and by definition, if other universes are causally disconnected from ours, we can never observe them directly, but they serve a purpose in helping us understand why our universe has the properties it does. In a multiverse, the physical constants don't need to be uniquely determined by theory, but can vary from universe to universe. And we find ourselves in one where the constants allow for stars, planets, and life, simply because those are the only universes where observers can exist to ask the question. The multiverse is the ultimate expression of the Copernican principle. Not only are we not at the center of the solar system, not at the center of the galaxy, not in a special galaxy, but perhaps not even in a unique universe, just inhabitants of one bubble among infinitely many in an eternal cosmic froth. As we drift through these contemplations, moving from the concrete to the theoretical, from the observable to the speculative, we find that the boundary between science and philosophy becomes increasingly permeable. The deepest questions about the universe, why it exists, why it has the laws it does, what came before the Big Bang, whether there are other universes, approach the limits of what science can answer and begin to shade into metaphysics. And yet, even in the face of these ultimate mysteries, there is comfort in the knowledge that the universe is comprehensible at all, that the laws of physics discovered in laboratories on Earth apply equally well to galaxies billions of light years away, that the mathematics we develop to describe one phenomenon reveals unexpected connections to entirely different phenomena, suggesting a deep unity underlying the apparent diversity of nature. The journey through the cosmos that we have undertaken together, from the sun's gentle vibrations through the violent collisions of neutron stars to the quiet evaporation of black holes in the unimaginably distant future, reveals a universe that is simultaneously more strange and more beautiful than our everyday experience would suggest. It is a universe of extremes, temperatures ranging from near absolute zero to billions of degrees, densities ranging from the near-perfect vacuum of intergalactic space to the incomprehensible compression of neutron stars, scales of size ranging from the quantum foam to structures hundreds of millions of light years across. And yet, for all these extremes, it is also a universe of patterns and regularities, governed by laws that we can discover and understand, filled with structures that arise inevitably from the interplay of fundamental forces. A cosmos that is both chaotic in its details and ordered in its overall evolution. You are lying in darkness, but you are also lying in a universe that glows faintly with the light of 400 billion stars, that hums with the vibrations of pulsars and the oscillations of the cosmic microwave background, that trembles with gravitational waves from colliding black holes, that expands steadily in all directions, creating new space with every passing second. The darkness around you is not empty, but filled with neutrinos passing through your body by the trillions every second, with the quantum vacuum fluctuating and creating virtual particles that briefly exist before annihilating back into nothingness, with the invisible web of dark matter that holds galaxies together, and the even more mysterious dark energy that pushes them apart. You are not separate from this universe, but embedded within it, made of the same atoms that form stars and planets, governed by the same forces that shape galaxies and drive cosmic evolution, a part of the great pattern that began 14 billion years ago and will continue for trillions of years to come. As your breathing slows and deepens, matching the slow rhythm of cosmic time, as your consciousness begins to dissolve at the edges and merge with the darkness around you, you can release all need to hold yourself separate, all need to maintain boundaries between self and cosmos. The atoms that form your body are not yours. They are borrowed temporarily from the universe, gathered for a brief time into this particular configuration before being released back into the cycle of matter and energy that flows through all things. The energy that animates you is not yours. It came from the sun, which received it from the fusion of hydrogen into helium in its core, which received that hydrogen from the cloud of gas that collapsed to form the solar system, which received it from earlier generations of stars, tracing back ultimately to the Big Bang itself. You are a pattern of organization that the universe has created, a way that matter has found to arrange itself temporarily into complexity and consciousness. And when that pattern eventually dissolves, the matter and energy will not be lost, but will flow onward into new patterns, new configurations, perhaps eventually into new forms of organization and awareness. There is no need to fear this dissolution, this return to the cosmic flow, because it is not an ending, but a transformation, a change of state from one form to another. The atoms that were once stars became the planet beneath you. The atoms that were once planet became living things. The atoms that were once living things became you. And the atoms that are now you will become something else, participating in the endless cycle of transformation that is the universe's fundamental activity. Nothing is created or destroyed in this process. The total amount of matter and energy remains constant, merely changing form, moving from one configuration to another in patterns that range from the simple to the complex, and back to the simple again in great cycles that span billions of years. And so you can rest, truly rest, knowing that you are held safely in the arms of a universe that is far older and far larger and far more enduring than any individual life. A universe that has been here for 14 billion years before you and will be here for trillions upon trillions of years after you. A universe that is in no hurry, that proceeds at its own stately pace, that cannot be rushed or delayed by any human action or inaction. The stars will continue to shine. The galaxies will continue to rotate. The universe will continue to expand, regardless of anything you do or fail to do. There is tremendous freedom in this realization. You are not responsible for maintaining the cosmos, not required to hold reality together through effort or will. It runs on its own, governed by laws that preceded you and will outlast you. And your only task is to exist within it, to experience this brief moment of awareness that the universe has granted you, to witness and wonder at the beauty and complexity that surrounds you on every side. The slow expansion of the universe is creating more space, more room for existence, more emptiness between the clusters of galaxies. In the far future, trillions of years from now, when all the stars have burned out and all the black holes have evaporated, and the universe has reached its final state of maximum entropy, there will be only scattered particles drifting in an ever-expanding void, so far apart that they will never interact again, existing in perfect isolation in a darkness that is absolute and eternal. And even this state, this heat death of the universe, is not truly death, but simply the final equilibrium, the state of ultimate rest toward which all things tend, the cosmic sleep from which no awakening is possible, because there is no energy differential left to drive change. It is the ultimate stillness, the perfect peace, the end of all struggle and all transformation, a state where time itself becomes meaningless because nothing happens to mark its passage. But that end lies inconceivably far in the future, a destiny so distant that it need not concern us now. For the present, we exist in a universe that is still young, still active, still filled with stars and galaxies, and the constant dance of matter and energy that creates the patterns we call reality. We have this moment, this awareness, this opportunity to experience existence from within, and that is enough. We do not need eternity, we have now. We do not need to understand everything, we can rest in mystery. We do not need to control or direct or manage the universe. We can simply allow it to unfold as it will, carrying us with it like leaves floating on a vast river, moving from the mountains of the past toward the ocean of the future, traveling a course that was determined long ago by forces beyond our influence or control. Let your breath become the breath of the cosmos, slow and deep and eternal. Let your heartbeat synchronize with the pulse of pulsars, steady and unwavering. Let your awareness expand to embrace the whole of existence, from the smallest quantum fluctuation to the largest cosmic structure, holding it all in a consciousness that is both yours and not yours, both individual and universal, both temporary and eternal. You are the universe experiencing itself. Matter become conscious. The cosmos looking back at its own reflection in the mirror of awareness. And when you sleep, you do not leave the universe. You simply allow your individual awareness to dissolve back into the larger awareness from which it emerged, returning temporarily to the source, resting in the deep cosmic sleep that precedes and follows all individual existence. The last photons of starlight that entered your eyes before you closed them began their journey years or decades or centuries or millions of years ago, traveling across the void at the ultimate speed, crossing distances so vast that they dwarf human comprehension, all to arrive at this moment at your retina, carrying their message from the distant past into your present awareness. Those photons have completed their journey now, absorbed into the chemistry of your vision, their energy transformed from light into neural signals, their long voyage through space ending in a moment of perception, a brief awareness of light that then fades as your eyes close and you turn inward, away from the external cosmos toward the internal landscape of dreams and rest. And in that turning inward, you carry the cosmos with you, because it exists not only outside, but inside as well, encoded in the atoms of your body, in the patterns of your neural connections, in the memories and images that float through your mind as you drift toward sleep. The universe is not something you observe from outside. It is something you participate in from within. And even in sleep, even in the deepest unconsciousness, that participation continues. Your atoms continue to vibrate. Your cells continue to metabolize. Your heart continues to beat, all driven by processes that are fundamentally cosmic, rooted in the same quantum mechanics that governs the behavior of electrons in distant stars, the same thermodynamics that drives the evolution of galaxies, the same gravity that holds planets in their orbits. So rest now, traveler through space and time. Rest in the knowledge that you belong here, that you are exactly what and where you should be, that your existence is not an accident or an anomaly, but a natural expression of the universe's tendency to organize itself into patterns of increasing complexity. Rest in the embrace of forces that have been operating since before the first stars ignited, forces that will continue to operate long after the last stars fade, forces that care nothing for your individual existence, but which nevertheless sustain you moment by moment, heartbeat by heartbeat, breath by breath. The universe is singing its slow song, the frequencies too low to hear, but present nonetheless, vibrating through the fabric of space itself. The pulsars are keeping time with their precise rotations. The galaxies are wheeling slowly through their orbits. The expansion of space is creating distance at a rate too slow to measure in human lifetimes, but inexorable over cosmic time. And you are part of this great symphony. A single note in a composition so vast that no one can hear it all. But every note is necessary. Every voice contributes to the whole. And your presence here, now, in this moment, is your contribution to the eternal song of existence. Sleep, then. Sleep deeply and peacefully, knowing that you are held safely in arms that have held countless worlds and stars before you, and will hold countless more after you. Sleep in the perfect darkness that is also filled with light too faint to see, in the perfect silence that is also filled with vibrations too low to hear, in the perfect stillness that is also moving at speeds too vast to perceive. Sleep in the universe, as the universe with the universe, all boundaries dissolved, all separation overcome, all questions released into the great cosmic mystery that enfolds all asking and answering in its infinite, patient, eternal embrace. The journey is complete. The circle closes. And in the closing, in the return to stillness and silence, and the deep peace that underlies all existence, you find what you have been seeking all along, not answers, not understanding, not knowledge or control, but simply rest. Pure, complete, total rest. The rest of atoms that have traveled for billions of years and can finally, briefly, be still. The rest of consciousness that has maintained itself through effort and will and can finally, briefly, let go. The rest of existence that has asked nothing of you, except that you be here now, experiencing this moment, and can now release you back into the darkness from which all light emerges, and to which all light returns, the cosmic womb of creation and dissolution, the eternal now that holds all time within it, the infinite here that contains all space, the perfect peace that is the ground of all existence, and the destination of all journeys, including this one, which ends now, here, in silence, in darkness.